Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. When the environment change, like with multipath transmission and scattering, wireless communication system experiences certain changes in the strength of their signal. This is called fading, which make hard to keep the communication reliable, and as it causes some changes in the quality of the signal received at the receiver and impact some system performances. In this unit, we will discuss fundamental concept of fading. We will compare fading and path loss, and we characterize the fading basic concept. And we also discuss different types of fading, and finally, we discuss about the model used for the fading. Fading is a phenomenon in wireless communication where the received signal strength fluctuates due to various propagation effects. It is primarily caused by multipath fading and multipath propagation, where multipath copies of the transmitted signal arrived at the receiver with different delays and amplitude due to reflection, diffraction, and scattering. Fading due to shadowing is also take place when propagation environment is changing significantly, and it is another cause of generating copies of the transmitted signal. But this type of fading is typically much slower than the multipath fading. Similarly, a fading channel is a communication channel that experiences fading. Fading and path loss are two distinct phenomena that affect wireless communication system, but both are have same contribution to the overall attenuation of the signal. Here we compare these two parameters, fading and path loss, in little detail. Fading refer to the rapid fluctuation in the system strength or amplitude of a radio signal over a short period of time, usually due to the changes in the propagation environment. Fading can cause signal strength to vary rapidly and leading to the fluctuation in the received signal power at receiver. Fading affects the reliability and performance of wireless communication system. While on the other hand, path loss refer to the reduction in signal power or signal strength as the radio wave propagate through space or encountered certain obstacle in their path between transmitter and receiver. It is primarily caused by the geometric spreading, absorption, and scattering of the electromagnetic signal energy as it travels from transmitter to the receiver. Path loss is deterministic in nature and typically follows a logarithmic relation with a distance and making it highly predictable based on the transmission environment. Now we can compare fading and path loss on the basis of nature because fading is dynamic phenomenon and that lead to the short-term variation in the quality of the signal strength. On the other hand, path loss is mostly deterministic phenomenon that causes a gradual decrease in the signal power strength with respect to distance. Another important parameter through which make the difference between fading and path loss is that fading introduces variability in the received signal strength. And most of the time, this variability is random in nature due to multipath propagation and changing environment conditions. While path loss represents a consistent decrease in the signal strength with respect to distance between transmitter and receiver. Mitigation. Many techniques in literature are available to manage both path loss and fading, but diversity, equalization, and adaptive modulation can mitigate the effect of fading, while path loss can be managed with the help of advanced techniques such as power management, and to the proper design and proper site plan. Understanding the characteristic of fading is very crucial for a proper design of a robust wireless communication system and implementing effective mitigation techniques. Characteristic of fading in wireless communication system can be defined on the basis of following factors, such as statistical nature. Fading is statistical phenomenon which can characterized by probability density function, cumulative distribution function, and power spectral density. These statistical parameters describe the distribution and overall behavior of the fading phenomenon. Similarly, propagation path is a multi-path propagation. Fading primarily occurs due to multi-path propagation, where the transmitted signal takes multiple paths to reach the receiver. This happens because of reflection, diffraction, and scattering from objects and surfaces in the environment. Each path can have different delays and amplitudes, leading to the constructive as well as destructive interferences on the receiver side. Similarly, fluctuation signal strength is another important parameter. Fading causes fluctuation in the received signal strength over time. The signal strength can vary rapidly in fast fading scenario or gradually in slowing fading scenarios. This variation in the signal strength can lead to the intermittent or momentary signal loss or degradation. Depth of fading. Fading can exhibit different depths, which refer to the magnitude of signal attenuation during fading. It is often measured in terms of signal standard deviation or the depth of fading, which is generally described in terms of decibel. A deeper fading depth indicates a greater degree of signal degradation. And duration of the fading is also an important parameter, and fading can have different duration depending on the relative speed of the transmitter, receiver, and even surrounding object. Fast fading refers to the rapid signal fluctuation over a short period of time, while slow fading involves gradual variation over longer duration. Spatial correlation can also disturb the fading parameters and fading because fading can exhibit spatial correlation where signal variation at the different locations are statistically related to each other. The correlation is observed in shadowing effect, where signal attenuation tend to be correlated over certain distances. Spatial correlation impact the design and development of wireless signal communication systems. And frequency selectivity is another very important parameter. Fading can be frequency selective, meaning that different frequency component of the transmitted signal experiences different fading characteristics. So this occurs when the channel introduce different amount of attenuation or distortion to different frequency components. And overall, the resulting is that frequency dependent fading is observed in such scenarios. And all these factors impact on the system performance because fading has a significant impact on wireless communication system. It can cause increased bit error rate. It can reduce coverage. It can decrease system capacity. So fading-induced errors can affect the reliability and overall the quality of the transmitted data, leading to the degradation of the system performance. Fading in wireless communication system can be classified into several types based on different characteristic and statistical models. Here are some common type of fading are being discussed here. Rayleigh fading. Rayleigh fading is a statistical model commonly used to describe the wireless channel in environment with multiple reflections and displacement. It assumes that there is no dominant line of sight component exists between transmitter and receiver in the received signal. Due to some blockage or some other many other reasons are exist that will be lost line of sight between transmitter and receiver. The amplitude of the received signal follows the Rayleigh distribution, which is characterized by the exponential power decay. Rising fading, which is another mathematical model, is used to define the rising fading here. And rising fading include a dominant line of sight compared to the in addition to the scattered path. This is the difference between Rayleigh model and Bayesian model. Bayesian model considers a dominant line of sight. It occurs in environment where there is a strong direct signal between along with the scattered signals. The amplitude of the result, received signal follows a rising distribution, which is characterized by the combination of dominant component and a Rayleigh distribution component. Similarly, multipath fading occur when multiple copies of the transmitted signal arrive at the receiver with different delays and amplitude due to the reflection, and scattering. It is a most common type of fading and is often abstracted, characterized by the combination of Rayleigh or rising fading model. Flat fading is another type which refers to the type of fading where the entire frequency band experiences the same amount of fading. It occurs when the channel response is relatively constant across the entire bandwidth of the signal. And another type is frequency selective fading. And frequency selective fading, also known as frequency selective multipass fading. Different name in literature you will find for the selective frequency fading. But it is a type of fading where different frequency components of the transfer signal experience different fading characteristics. It occurs when the channel introduces different amount of attenuation or distortion to the different frequency components, and resulting in the frequency independent fading. Another important type of fading is slow fading, and slow fading refers to the fading scenario where the variation in the received signal strength occur gradually over a relatively long period of time. And it is typically observed when the relative motion between the transmitter and receiver are very slow, or when the environment exhibits some temporal changes. Opposite to the slow fading, there is another type of fading, which we call it as a fast fading. Fast fading refers to the fading scenarios where the variation in the received signal strength occurs rapidly over the short period of time. It occurs when the relative motion between the transmitter and receiver is relatively fast, or when the environment exhibits many rapid temporal changes. These pattern types provide insight into the statistical models and characteristic of the wireless channel, helping in the design and optimization of wireless communication system to mitigate the effect of fading and maintaining overall reliability of the wireless communication system.